So, welcome to building cross-platform mobile applications with HTML5 and with PhoneGap. So, let me preface what I'm about to say here with this. There are lots of reasons that we're interested in HTML5 today. One reason that we're interested in it is because it allows us to write rich browser-based applications without plugins like Silverlight and Flash. But there are other reasons that HTML5 is interesting as well. And in fact, the reason that I'm primarily interested in it is because it is the beginnings. It's not a total solution, but it is a partial solution for building cross-platform mobile applications. Now, half of my professional career is spent working at Microsoft as a contractor. The other half of it is spent outside Microsoft, actually building solutions for customers, mostly in the US, but a few in Europe as well. And increasingly, customers are coming to us and asking us to build mobile applications for them. And oftentimes, they want that application to run on Windows Phone 7, on iPhones, on iPads, on Android devices, and others. But the last thing that that customer wants to hear is, we're glad to do that for you, but we're going to have to charge you for it 4 times because we have to write the app differently for each platform. What all of us would like to have, given that mobile development is going to be such a big part of the next few years of this industry, is a way to write that application one time and have it run not only on Windows phones, but on iPhones and iPads and all kinds of other devices as well. HTML5, as I said, is part of the solution for doing that. So I put this session together because I want to show you what the state of cross-platform development looks like today with HTML5, and with the aid of a little library called PhoneGap, which you may have heard of or may not have. If you haven't, that's okay, because I'll be telling you exactly what PhoneGap is and showing you what it helps me to do, what it will not, what it does that HTML5 will not. Before I even do that, however, I want to go over into Visual Studio and run something for you. And by the way, at the end of the session, the final slide, I'm going to give you a URL so that you can go download all of these examples that I'm going to run if you want to run them for yourself. So what I'm going to do, make sure I'm on the screen back there. I am. Wish that screen were just a little bit bigger, huh? I'm going to go into my samples, and I'm going to bring up a Windows Phone 7.1, a Windows Phone Mango sample. So it's called HTML5 demo. I originally wrote this sample for a simple reason. In Windows Phone 7.0, we didn't really have the infrastructure needed to write cross-platform mobile applications. Its browser was based on earlier versions of IE, which did not support HTML5. To me, one of the most exciting features of Windows Phone Mango was the fact that its browser is based on IE9, which supports most of the HTML5 features that I need to write cross-platform mobile applications. Now, this project that I have open here is a Windows Phone 7.1 project. I'm going to run it in the emulator here so you can see what it looks like. We'll give the emulator just a moment to start up. But what's significant about this is the Windows Phone application itself is just a shell. All the UI and all of the logic for this application are written in HTML5 and JavaScript. So we'll let this thing start up in the emulator. I've got it on my actual phone too. I may run it there a little bit later. But what this application does is very simple. It uses HTML5's Canvas API to take an image, to cut it up into little squares. Each square is a separate canvas, by the way. And then I'm using jQuery to do some mouse event handling. And when the user clicks or on a phone touches one of these squares adjacent to the empty square, I use jQuery animations to move that square to the empty one, like that. Now again, when you look at this application, all the UI and the logic is HTML5 and JavaScript. You can see that I have this folder named Assets. In it is an image file named scene.jpg. That's the image that I carve up into little pieces so you can move the pieces around. jQuery.js, that is jQuery, which I'm using just to provide some interesting abstractions. And most of the action happens here in puzzle.html, where you see my HTML defined. In fact, the UI for this app is nothing more than a whole bunch of canvases that you see here. And you see some JavaScript code that does this, When this application starts up and jQuery's document ready function is called, I programmatically load scene.jpg. In this nested for loop, I'm using the Canvas API to carve the image up and paint individual pieces of it onto those canvases that you saw. Then I use jQuery to wire up a click event handler to each of those canvases so I know when it's been clicked or touched. And here in the click handler, I'm using jQuery animations to make those pieces slide around. So again, it's all HTML5 and JavaScript. You can't tell that from the outside. It looks like a native phone app. There is a component of this, however, that is native to the Windows Phone. It turns out that if you want to run HTML5 apps on a Windows Phone, what you do is make your UI a web browser control. Then you programmatically write into isolated storage all of your HTML and JavaScript assets. So in addition to this HTML and JavaScript stuff here, if you look in mainpage.xaml, you'll see that I'm doing a little bit more. Each time this application starts up, for example, I'm going into isolated storage for this app. I'm checking to see if those HTML and JavaScript assets are already in local storage, if they exist there as virtual files. And if not, I call this helper method named createFile to add them to isolated storage. What's important about isolated storage to a Windows Phone is that if I deploy a more complex HTML5 application, one that has multiple pages and links allowing the user to navigate between pages, those links can be resolved from isolated storage just like links on the web can be. So what we have here is an HTML5 app running on a Windows Phone, looking for all intents and purposes like a native app, with some glue code, if you will, that I've had to write in to really allow this thing to work as an HTML5 application. Now, this is the first step in understanding cross-platform mobile development today. I can take the same HTML and JavaScript assets and I can take them to an iPhone, I can take them to an Android device, I can take them to an iPad, and they will work exactly the same way there because all of those devices support HTML5 and JavaScript. One hurdle I'm going to have to clear, however, is I'm going to have to know enough about iOS development and Android development, etc., to build this glue code here, to know how you present an HTML5 app on those platforms, and know how to write just enough native code to package that application up. And that's a non-trivial hurdle, as you can imagine. I've done a little Android development. I don't know a lot about iOS. Hey, I may want this thing to run on a BlackBerry device too. They support HTML5. So even if I do get my iOS developer's license and do everything I need to do to package this as a native iOS app, what about BlackBerry? What about Symbian? What about all those other devices, even mobile platforms that don't even exist yet? How am I going to support those platforms? So with that, let's go back to the slides. Obviously, HTML5 is one important component of cross-platform mobile development. But HTML5 won't do everything for us. I still have to know enough about the individual platforms to package them up. In addition, HTML5 doesn't provide all of the APIs that I need. For example, HTML5 does not yet, at least, have a touch API, meaning it's very difficult, sometimes impossible, to build a cross-platform mobile application that allows the user to use a pinching gesture to zoom in or zoom out. There are currently no other mobile-type APIs in HTML5 to let me access the device's accelerometer to find out what the battery status is. Now, a lot of this is being added to HTML5. It's going to be a couple of years before a lot of this actually shows up. But for now, what we use to fill the gap between what we want to do on that phone or tablet and what HTML5 will do is a free open source framework named PhoneGap. Now, PhoneGap has been around for a while, but it's only in recent months that it has come to support Windows Phone. It was actually a small team at Microsoft in Redmond that built the Windows Phone 7 support into PhoneGap. Version 1.3, which came out a couple of months ago, was the first one to support Windows Phone. Like almost every first release of every product, it had a few bugs. Recently, they released version 1.4.1, which fixed a lot of those bugs. It's not a perfect platform, it's not a perfect framework, but you're going to see that by combining HTML5 and PhoneGap, I can go a long ways towards building true cross-platform mobile applications. Something else you're going to see in the demos that I do is that there's no such thing as a free lunch. You give something up when you go cross-platform. For example, on a Windows phone, when I'm building a native app for the Windows phone, I can use cool controls like the panorama control to present a really, really nice UI. Well, that panorama control doesn't exist on other platforms. So the moment I decide to go cross-platform, I give up some of the best features of the individual platforms. But oftentimes, I gain more than I lose. I do gain the ability to write an application that's going to run on all those different devices, and I only have to write the thing one time. Again, one of the two big things that PhoneGap does for you is it fills the gaps between what we want to do in JavaScript and what HTML5 will allow us to do. In fact, that's where the name of the product came from. There's something else that PhoneGap does for us, however. There's a service out in the cloud called PhoneGap Build. It's currently in beta. It's completely free. It may not be completely free once it's out of beta. That's undetermined as of yet. By the way, PhoneGap was originally created by a little company called Natobi, but they have recently been acquired by Adobe. So this service out in the cloud is called PhoneGap Build, and here's the really cool part of it. If I use, say, a Windows phone as my primary development device, which I do, I build, I test, I debug, I polish off that app using Visual Studio, the Windows Phone emulator, and a real Windows phone. I can then create a little zip file with the HTML and JavaScript assets, upload them to PhoneGap Build, and it will build native packages for all those other devices for me, for iPhones, for iPads, for Android devices, etc. Now, I know you probably don't believe that. You think I'm just blowing smoke, right? I'm going to show you. We're going to build something with PhoneGap Build so you can see what the process is like. Now, before we do that, let's talk a little bit about what PhoneGap does for you API-wise. So this is actually a snapshot from the latest PhoneGap documentation. On the left, you see a list of the different APIs that PhoneGap gives you. Now, some of these overlap with HTML5 APIs. For example, the geolocation API. Virtually every mobile device today that supports HTML5 supports that natively, so you don't need that in PhoneGap. But there is, for example, no accelerometer API in HTML5. But guess what? PhoneGap provides that API. So if I want to build a labyrinth-type application where there's a ball moving around on a table or something like that, normally I can't do that in HTML5. But with PhoneGap, I can through its accelerometer API. It provides other APIs as well. There is no HTML5 JavaScript API for accessing cameras, microphones, things like that in a typical mobile device. PhoneGap, however, provides those APIs. It provides APIs for accessing the phone's contacts, for accessing the phone's calendar, for doing a lot of other things as well. Now, over time, and it will be a few years, over time, the need for PhoneGap will go away as HTML5 continues to grow and continues to gain more and more features for mobile devices. But for today, for companies that are doing real cross-platform mobile development, a lot of them are using HTML5 and PhoneGap. By the way, PhoneGap isn't the only framework out there. There are others. I've played with some of those. I haven't done nearly as much with them as I have with PhoneGap. PhoneGap is the one so far that I have found to be the most robust and the most feature-filled in terms of letting me do in a cross-platform app the kinds of things that I want to do. So let's take a look at what a project looks like that uses PhoneGap. So what I have already done here is gone out to the PhoneGap website and downloaded the latest version, which is 1.4.1, and installed it in Visual Studio. It's a very simple process. And because I've done that, if I create a new project, one of the options I now have is that of creating a PhoneGap project. What that does is simply uses a template to spit out a Windows Phone 7 project that already has the structure the PhoneGap needs and also has the PhoneGap.js file. By the way, there are two components that really make PhoneGap up. Let me show you what those look like. In fact, what I'm going to do is open a PhoneGap version of that same puzzle application you saw just a moment ago. This is one of the projects in the zip file that I'll give you the URL for at the end of the session. So let's go into my PhoneGap 1.4 folder. I'm going to open something called PhoneGap Puzzle Demo. Now, we'll let Visual Studio run that. I'll close this off because I don't need it just yet. But let me show you what's different about this project and a normal Windows Phone 7 project. Number one, when I created this project as a PhoneGap project, automatically included in the project was something called WP7gap ClassLib.dll. That is an assembly that PhoneGap calls into so that it can implement its own APIs by going down to the native Windows Phone APIs. Now, in my code, I never call into that thing directly. Another really important piece of the puzzle that was added to my project for me is something called PhoneGap 1.4.1.js. This is where PhoneGap's JavaScript API is implemented. If you look in the index.html file that Visual Studio created, it already contains a script element that brings in that file. That file is there's a different version of it for each different platform that PhoneGap supports. This obviously is the PhoneGap JS file for the Windows Phone. That gaplib is also a per-platform binary. If you were using iOS, for example, or a Macintosh, let's say, to do your development, you would have a similar project structure. You would have a PhoneGap.js file, but one that's specific to the Mac OS, and you would have a gap lib for it as well, which is specific to iOS. Now, the most important folder in a PhoneGap project is the one named www. This is where you put all of the HTML assets, JavaScript assets, and other assets that make up your application. In fact, what I've done there is taken that same scene.jpg file that you saw in the app I showed you a moment ago, and I've added it to the www folder of my PhoneGap project. By the way, be sure when you add an image to a PhoneGap project, you must, absolutely must, go down and change its build action from resource to content. Otherwise, the image will never show up. In addition, I've brought in the jQuery file because you saw that this application does use jQuery. And Visual Studio created index.html for me. Initially, it was pretty empty. I basically took that JavaScript and HTML from the other project and just copied it over. This file is almost identical to the one you saw in the previous project, except for two things. Number one, notice that I am including PhoneGap.js. And number two, and Visual Studio actually generated this line of code for me, by the way, we're registering when the application starts up a handler for a special event named device ready. This is one of about a dozen different events that PhoneGap itself fires. It's kind of like a jQuery ready handler, but normally, not always, normally it actually fires after the ready handler. Bottom line, and before this event fires, you're not guaranteed that PhoneGap is up and running and initialized. So just as in jQuery, we normally put our startup code in a ready handler or ready function, in a PhoneGap application, we always put that startup code inside that device ready handler. Then we know everything's going to work as intended. And what do you see if you look inside this one? Well, you see the same code, which I literally copied and pasted over from the other app. The JavaScript code that cuts up the image, paints pieces of it onto those individual squares, jQuery code to register a click event handler for those canvases, and the event handler right here. In other words, I didn't have to know anything about Windows Phone 7 itself. All I had to do was know a little bit about PhoneGap and know how to bring those HTML assets over. Now, what happens if I run this application right now? Let's see, I'm still pointed at the emulator, so I'm just going to run it there. We'll see the emulator come up. And look at that. Looks exactly the same to the user. Again, all of our UI, all of our logic is done in JavaScript. But I haven't had to write a single line of C# code or any other code that's specific to WP7. Under the hood, what's happening here, by the way, is PhoneGap provides its own version of the Windows Phone web browser control. It basically provides a user control that wraps the built-in web browser control. but that special variant, if you will, of the web browser control that PhoneGap gives you automatically each time the app starts up goes and takes all the assets that make up the app and stuff them into isolated storage. So now I have an application built and tested using Visual Studio and Windows Phone, but it is a PhoneGap application. So in theory now, I could take this thing and I could deploy it to other devices, Android devices, for example. That's where PhoneGap build comes in. Right now, I just have a WP7 binary. If I want to deploy this to other devices, if I want to create native binaries for them, I'll need PhoneGap build. So let's go back to the slides here for just a moment. PhoneGap build, again, is a service in the cloud, currently free, may not stay that way forever, but at least for now it's free. It's very simple to use. I'm going to demonstrate it for you. You take the HTML and JavaScript assets from your project, zip them up or put them on NuGet, pass them up to PhoneGap build, and it builds binaries for all of the other platforms for you. Now, let me warn you about one thing. When I run PhoneGap build in a couple of minutes, you're going to see it building iOS binaries and Android binaries and all that. It will not actually spit out for me a Windows Phone binary. They're late on that. They were actually working on that. Natobi was when they were acquired by Adobe. They've been delayed just a little bit, but they tell me, they promise me that very, very soon, among the binaries that PhoneGap builds will be Windows Phone 7 binaries. It's not there yet. But I don't care about that in this case since I'm building native Windows Phone binaries here myself. Before I show you PhoneGap build, I want to mention to you a special file. Technically, the only thing you have to input to PhoneGap build to get all these native binaries built for you is index.html. It will provide the PhoneGap.js file for you. It will provide other necessary stuff. If there are other assets in your app, like images and other JS files you rely on, you include them in the package you upload to PhoneGap build as well. Config.xml is an optional build configuration file, and in fact, it is not fully supported yet because remember, PhoneGap build is still in beta. But what it allows me to do, and will allow me to do more of in the future, is tell PhoneGap build exactly what I want it to build. I can tell it, for example, that I don't care for a BlackBerry binary. I only want it to build packages for Android and iOS. Another thing that's important about this file, and this is something that will cost you a lot of time the first time you run into it if you don't know about it. If you're familiar with the Windows Phone, you know that every phone application has embedded inside it something called an application manifest. And one of the things expressed in the application manifest is a list of so-called capabilities. For example, if a Windows Phone Mango application is going to access the phone's contacts, you have to put a special capability flag in the manifest telling the OS you're going to do that. Otherwise, it will throw an exception when you try to access those contacts. Other platforms, some other platforms, have similar capabilities flags and even similar manifests. Android, for example, does require you to flag certain capabilities of the application for it to even be deployed and executed on the phone. Since I'm using Windows Phone 7 as my native testbed, if you will, I edit the application manifest right there in Visual Studio. But when I pass that up to PhoneGap build and ask it to build an Android package for me, I have to have some way of expressing to PhoneGap build that I want those capabilities expressed in the Android manifest it generates as well. And the way I do that is through config.xml. In this example here, and this does work, I just tested it a couple of days ago to be sure, this feature element you see at the bottom tells PhoneGap build that this application does access the phone's contacts. Now, if I ask it to generate an Android package, it will include a manifest that expresses that. And once PhoneGap build comes to support Windows Phone 7 binaries, it will automatically include in Windows Phone manifests similar capabilities flag. But enough about that. Let's see PhoneGap actually working. I should say PhoneGap build. So here's what we're going to do. We're going to take that HTML5 and PhoneGap puzzle application I showed you a moment ago. We're going to package it up as a zip file. We're going to upload it to PhoneGap build and see what we get back. So let's do that. First thing I'm going to need to do is create a new zip file. So let's go fire up WinZip here on my box. And let's see here. Okay, let's put this over in my Scratch directory. And let's call this PGB for PhoneGap build. So create a zip file named pgb.zip. Now, let's go into the project folder there, PhoneGap puzzle demo. Go find the www folder. And, oh, I just remembered there's one thing I need to do before I do this. Last thing you do before you ship it up to PhoneGap build is get rid of this version number right here. And the reason for that is PhoneGap build is going to provide in each native package that it generates the proper version of PhoneGap.js. And it calls it PhoneGap.js. So the HTML file in those packages need to reference it that way as well. So now that I've made that change, now let's go back to WinZip and finish creating this package here. So I'm going to put in the zip file index.html, the jQuery.js file, which I'm using, master.css, that's a very simple CSS file, a style sheet that was included in the project by Visual Studio. I haven't done anything in there, so technically I could leave it off. Scene.jpg is one of the assets. I'll include that. You don't need to include the PhoneGap.js file because remember, that is a per platform file, and PhoneGap is going to provide the right version of it for each binary that it builds. So I'll add those all into the zip file, and now I'll go to my browser and I'll fire up PhoneGap build. And let's see here. PhoneGap build. And I'm already logged in here. I went in and set up a free account. And I've actually, I'm going to delete this right here because this was left over from my testing. So let's go in here. I don't want to do a rebuild all. Actually, what I want to do is edit. And danger zone, delete this app. We are going to delete it. Yes, delete it. Are you sure you want to delete it? Yes, I want to delete it. So now what I'm going to do is click the new app button. We'll give this thing a name. Let's call it Puzzle Demo. And let's see, if I want PhoneGap to generate debug binaries for me, I can check this box. This is fairly new. And select my upload method. I'll select upload an archive or zip file. Now I'll go browse for that zip file. Should be over in my Scratch directory. And let's see here. What did I call it? I called it pgb.zip. And now we're going to submit that to PhoneGap build. And watch what happens. So that's going up to PhoneGap build right now. And if I click Puzzle Demo, we see that, has it built any binaries for me yet? It has not, but we're going to refresh the page. Usually it takes a minute or two. And let's see, do we have any binaries yet? Still no binaries. Because we're having to wake PhoneGap build up just a little bit. Let's wait just a... We have a WebOS binary right there, complete with a QR code. If we wait just a moment and click refresh a time or two again, I'm really looking for that Android build. Sometimes it seems to come in last. It's like we have a Symbian binary that we can download now containing those assets. Maybe the fifth time's a charm. Oh, look at that. We have an Android binary. And what I can do now is click this download link to go download an Android APK file, which is really just a zip file. You can look inside it and see what's there. Or what I generally do is use an Android phone with a QR reader on it. I just point the phone at that QR code, and it downloads and installs the binary for me. So I don't actually have an Android phone with me to demonstrate it, but if I did, we could use that QR code, and in about 10 seconds from now, we could be running that application on an Android phone, and it would look almost exactly the same way there that it looks like on a Windows phone. So we're going to spend time looking at the PhoneGap API, but the big picture is this. PhoneGap now supports Windows Phone. PhoneGap Build will soon support it as well. You can use the Windows Phone as your native testbed, or you can use any of the other mobile device operating systems and tools if you prefer. Once you have built and tested and debugged and you're ready to go, you simply create a zip file with your HTML and JavaScript assets, upload it to PhoneGap Build, and it builds the native binaries for the other platforms. So to the extent that you can use HTML5 and the PhoneGap API, which supplements HTML5 to do what it is you need your app to do, you can build cross-platform binaries this way. By the way, you notice it hasn't built an iOS binary for me. One of the things I love about a Windows phone is you can, if you're a registered developer, You can run and test apps on your phone that have not been signed. But even when you deploy those things to the Windows Phone marketplace, you don't have to do the signing. Microsoft signs those things for you. It's a little bit different over in the iOS world. You have to go register as an Apple developer, and you have to provide a certificate to PhoneGap Build so that it can sign the application. Over in the iOS world, it's not Apple that signs the packages. It is the developer that signs the packages. I don't have that certificate. Therefore, PhoneGap Build will not currently build an iOS version for me. I could go through another web page here in the PhoneGap Build site, provide that certificate that I received from Apple, and then it is perfectly willing to build iOS binaries for me as well. Does that all make sense so far? Do you like what you see so far? Okay, let's start talking details. What can you do with PhoneGap? What can you not do? I told you earlier there's no such thing as a free lunch. One of the things I want to do here is I want to show you some of the same applications on my Windows Phone running side by side as native Windows Phone apps leveraging the Windows Phone API and as PhoneGap apps. Sometimes those PhoneGap apps don't perform as well, and you can see the difference. I'm not trying to knock PhoneGap. It's just the nature of HTML5 and JavaScript. What I want to do is make sure you've seen some of these so you can do apples to apples comparisons, and you can make an intelligent decision, an informed decision as to whether or not this is something you want to pursue. In other words, I'm not here to sell you on it. I'm here to inform you about it, and then it's your decision whether you want to go forward and invest in this some more. So with that said, let's pop back to the slides for just a moment. So let's start talking about PhoneGap APIs. And we'll start with the simple stuff. So one of the categories of APIs that PhoneGap gives you is the notification API, which consists of these four methods right here. Now, on some mobile devices, you can call window.alert in an HTML5 app, and that device will show an alert box for you. Windows Phone won't do that. So if you want to do something like pop up an alert box or confirmation dialog in a PhoneGap application, you use this API instead, and then it's guaranteed to work on all of these devices. As an example, if I wanted to pop up an alert box and I want to make sure it's done in a cross-platform way, I call navigator.notification.alert, and I pass in the message that I want to appear in that alert box. Almost every mobile device has a different way of showing that alert box, and the Windows Phone is no exception. There's another API in PhoneGap called the Connection API. It's a very, very simple API. It allows your cross-platform mobile application to find out whether it's connected to a network or not, and if it is, what type of network it's connected to. If you find you're connected to a cellular network, for example, you may refrain from doing a few things, downloading large images or something, that you would have no problem doing if you were connected to Wi-Fi. So here's how you get that information in PhoneGap. It's very, very simple. If you want to find out at any time in the lifetime of your app whether you're connected and what type of connection you have, you call Navigator Network Connection Type, as I'm doing right here. Then you take that value that comes back. It will be one of the values you see in those array indices on the left, and that tells you precisely what type of connection you have, or if you don't have one, that you don't have one at all. Another API set that PhoneGap gives you is the device API. Now, virtually every mobile operating system has its own platform-specific API for getting information about the device you're running on, about its unique ID, about what operating system it's running, what version of the operating system it's running, etc. But we need a way to get at that kind of information in a cross-platform app as well. And HTML5, of course, doesn't have that API. PhoneGap does. This, too, is a very, very simple API. And here's what it looks like. It allows me to get the name of the device. For example, on my Samsung Focus here, it'll either tell me Samsung Focus, or actually what it'll tell me is Jeff's Focus, since that's what I named that device when I set it up. It will also give me the GUID that uniquely identifies this device anywhere in the world, tell me what version of PhoneGap it's using, and through the platform and version properties, tell me what operating system and operating system version this particular device is running. It's kind of interesting. If you run this on a Windows Phone and look at that platform and version, it doesn't tell you it's Windows Phone 7.0 or Windows Phone 7.1. It tells you it's Windows CE. interestingly enough, followed by some version information. But from that, I could figure out at runtime, am I running on an Android phone? Am I running on a Windows phone? Or what have you, in case there's logic that depends on that. Another component of the PhoneGap API is a set of events that it fires at various points during an application's lifetime. The most important of these is that device ready event. And you've already seen that when you create a new project, a new PhoneGap project in Visual Studio, the index.html file that's generated for you already includes that call to add event listener to register a handler for the device ready event. And it also includes an empty handler just to prevent you from having to code that. But there are other events as well. Pause and resume turn out to be particularly important. If you've done any Windows Phone programming, you know that when a phone application is not in the foreground, it is suspended. Typically, the process image remains in memory, but its threads are suspended, so it gets no CPU time. But just like Windows 8 Metro, a suspended app is subject to termination at any time. If that termination occurs, the user isn't going to like the experience that they get when they switch back to your app because all the data will be gone. Now, some platforms are a lot more forgiving, or a little more forgiving than Windows Phone is about that, but knowing that Windows Phone is one of the targets for the apps I'm building, I will use these pause and resume events, just like I use native events on the Windows Phone to know when my application is being suspended and resumed. Just before it's suspended, I'll write out into HTML5 local storage everything that I need to recreate the state of that application. And when the resume event fires from PhoneGap telling me I've been unsuspended, I will restore that state to guarantee a good user experience, even if the OS chooses to terminate that application while I'm away. There are also events to let you know if the battery is low or if it's critical. There are a couple of other battery-related events that I haven't shown you here. Let me mention this. Just because the event or API exists in PhoneGap doesn't necessarily mean it's supported on every platform. Today in Windows Phone Mango, there is an API in Mango for getting battery information, some battery information. There are no events firing from the OS that let PhoneGap fire events of its own when the battery gets low. So some platforms support some of these events, but few platforms support all of them. You will not see a battery low event or a battery critical event, for example, on a Windows phone, whereas you will on iOS and Android. A couple of examples here. Again, device ready is probably the most important of these events. This is PhoneGap's indication to you that it is up and running and ready to go. While it's fine to execute JavaScript code that doesn't use PhoneGap before this event fires, you never, ever, ever want to make a call into a PhoneGap API until after this event has fired. Perhaps more importantly, the pause and resume events, program lifecycle management. When that suspend or the pause event fires, that means your app is being suspended on whatever platform it's on. Save your state right there. Then when the pause event fires, restore the state. Now, here's a great example of how when you use abstractions like this, you sometimes suffer for it performance-wise. On the Windows Phone, when you write a native application, it tells you when the app is suspended. It also tells you when it's unsuspended, and it passes information to the event handler telling you whether the application was actually terminated while it was suspended. If you find it wasn't terminated, then you don't have to go to the trouble of restoring the state that you saved out just before the suspension occurs. In PhoneGap, there is no additional information accompanying a resume event. So, of necessity, I'll save my state every time I get a pause event, and I will restore it every time I get a resume event, even though in actuality, I probably didn't need to do that. Since PhoneGap doesn't give me any additional information, though, telling me whether I was terminated or not, I really have no choice. Let me show you an example here. Let's go back to Visual Studio. And I want to run another PhoneGap application here for you that demonstrates the use of these pause and resume events. This one is called PhoneGap Lifecycle Demo. And one of the things I want you to notice about this project is I've leveraged this new feature of Windows Phone Mango that allows me to test my tombstoning code by having it terminate a process that is suspended. Or at least I thought I had the box checked. I did not. I do now. What this does in Mango, and if you've built native Windows Phone apps, you probably know this already. In Mango, apps are rarely ever terminated after they're suspended, just the opposite of Windows Phone 7.0. That means when you write what we call in Windows Phone tombstoning logic to save and restore state, you're never really sure that your logic is sound, that you've gone through all the code paths unless you can force the application to be terminated while it's suspended. Checking this box in a Windows Phone Mango project does that. It simply tells Visual Studio that when this application is suspended, we want it to be terminated. Only then can we fully test our tombstoning code. Since I'm going to test that in a PhoneGap app, I need that same checkbox checked. So let's save that. Then I'll close that out. And let me show you what this application looks like. We'll run it in the emulator. I will run some stuff on my device in a moment. And this is a very simple data entry type application. It's actually the kind of thing PhoneGap lends itself to really, really well. Instead of XAML text boxes, these are HTML input fields that you see. And I'm going to do some simple data entry here. So let's do this. And then do a little typing here. I'll type my name in here. Type my email address. Whoops, not there, but down here. Yeah, stuck that time. Whoops. And I'll type a mobile number as well, and I really messed that up. Let's see if I can fix that up. I have to bend down a bit so I can see the screen. There we go. And finally, I'll type a phone number, and I'll just put some random digits in there. So we're now going to force this application to be suspended. And because we've checked that box in Visual Studio, that means it's going to be terminated as well. If we are All right, can you hear me again? Yeah. So if I'm not properly handling state management in here, then we're going to see this data go away when we switch away from the app, forcing it to be terminated, and then come back. So here's an easy way to force a suspension on a Windows phone. What I'm going to do is just click the Start button to go back to the Start screen. My application was by definition suspended because it's no longer the foreground app. Because the checkbox I checked in Visual Studio, the process was terminated. Normally, if the user then presses the back button to go back to that app, it's a fresh launch of the app. All the data is gone. But you notice the data is still there. I have created the illusion for the user that the application was never terminated at all. What am I doing to do that? I'm leveraging those pause and resume events in PhoneGap. Let me pull my glasses back out here. It's one thing about getting old. I've had perfect vision most of my life, but these days I can't read a computer screen without these little $10 magnifying glasses here. I can't read a menu in a restaurant either, so I have to carry these things with me wherever I go. So take a look here at what's really important about this app. So here is the ever-present line of code that registers handler for the device-ready events. And in that event, I'm registering JavaScript handlers for PhoneGap's pause and resume events. Very simple. When this onPause method is called, indicating my application is about to be suspended, I take all the data that's required to recreate the state of this app, which in this case is nothing more than what the user's typed into those 3 text boxes, and I write them into HTML5 local storage. Then, when the app is resumed, that is, if it's resumed, there's never a guarantee that the user will press the back button to go back to it, but if it's resumed, I reach into local storage, and if those items are there, I use them to restore what the user had typed into those text boxes. Then I remove those items from local storage so that the next time the user restarts the app, if it was a fresh start, a fresh launch of the app, the text boxes won't be pre-populated. So a little bit of work with the pause and resume events, and I can handle lifecycle management properly, not just on Windows Phone, but on other mobile operating systems as well. Okay? Now, let's go back once more to the slides. That's all fine and good, but I know what you're thinking. You're thinking, okay, Jeff, I get it, but those are pretty boring apps you showed me so far. How about some more exciting apps, okay? One of my favorite components of PhoneGap is the accelerometer API. I guess until I started writing phone apps for the Windows Phone, I really had no idea how empty my life was without an accelerometer API. I had no idea how useful they are when you can build applications that respond to the 3D orientation in space, when you build applications like the Windows Phone Facebook app that understands when you shake it. It's so cool to have an accelerometer API. And guess what? One day there's going to be one in HTML5. People are beginning to work on that now. But today, if I want to use that accelerometer, I need PhoneGap. Now, it provides me with an accelerometer API, which is not unlike the one that Windows Phone gives you and that other operating systems like iOS give you as well. If you want to read accelerometer data, what you do is this. You call watch acceleration, and you provide a callback function, a success function. Now, at the intervals that you specify, in this case, I'm asking for these callbacks to be fired at 50 millisecond intervals, or about 20 times a second, PhoneGap is going to call my success function, assuming it's able to read the accelerometer, and it's going to pass me normalized vectors describing the acceleration being exerted on that phone in the X, Y, and Z directions. It's pretty rudimentary data. That's exactly what you get in a native Windows Phone app. You get normalized acceleration vectors, but from that, you can build applications that recognize exactly what orientation that phone is in, that respond to changes in orientation and things like that. So, one other thing too here, remember that some devices, Android devices and Windows Phone devices in particular, do require flags in their manifest indicating that they access certain devices like the accelerometer. It's interesting, when you create that new PhoneGap project in Visual Studio, unlike a normal Windows Phone project, which has a default manifest that lists all the capabilities so you can test anything, the application manifest in a PhoneGap project has a bare minimum set of capabilities. Unless I go in and add this to the manifest, that highlighted line in orange, the accelerometer will not work on the Windows Phone. I will generate an exception every time I call watch acceleration, so it's important to go in and add that to the manifest manually. Once I know how to do that, then I can use the accelerometer. Now, what I'm going to do here is switch over to my phone using this little device right here. First time I've ever seen one of these, but I think I'm going to have to buy one. It's a little USB camera, essentially. Costs less than $100. Oftentimes at conferences we use these big multi-$1,000 Wolf Vision devices. This actually puts out a better image. Let's wake my phone up there. And I've actually built this thing in two versions. I'm first going to show you the native Windows Phone version so you can see what it looks like. And it's called Accelerometer Motion Demo. And it is that prototypical ball on a table application. And I'm going to lift the phone here, and you can see that as I tilt it, the ball is bouncing around. I used some high school level equations of motion to do this. Had my 13-year-old daughter play with it until it felt natural with the damping factors, the mass, and all that. And you can see that, boom, it just gets down there and settles in nicely. If I do that, it's going to go settle in nicely there. So that's the native version of this application. But that application won't run on an iPhone, an Android phone, or others. What about the PhoneGap version? Well, let me show you the PhoneGap version of this. I'll show it to you on my phone, then we'll go look at the code here. So here's what the exact same thing looks like in PhoneGap. I'm now using PhoneGap's accelerometer API. And it's a little bit hard to tell because of the refresh rate on the camera, but can you tell I'm not getting as many screen updates per second as I was in the native version? The native version of this, when you're standing over the phone looking at it like I am, it looks and feels very realistic. The phone gap version, however, I haven't measured the frame rate. I'm guessing I'm getting about 10 frames per second. It's good, but it doesn't feel as natural. It looks like it's a little bit jerky. That's a consequence of the fact that we're not going right into the Windows Phone OS, that we have this layer, this JavaScript layer, sitting between us and the Phone OS. Still, it's pretty acceptable, and in fact, I wouldn't feel bad at all in deploying this as a cross-platform mobile application. So, let's see what it takes to do that. How did we write that application using PhoneGap? So here's what I did. Pretty simple. Let's go back to Visual Studio. I'm going to open a project named PhoneGap Accelerometer Demo. And here's what it looks like. So as usual, you have in this PhoneGap project the www folder. I put my assets in there, which includes a PNG image of that shiny ball that you saw, index.html. I also have another image, a JPEG, which provides that background that you saw. Everything else is really just code in here in index.html. In that JavaScript code, let's go a little bit further down. In device ready, you can see me calling watch acceleration on PhoneGap. And what kind of frame rate am I asking for? I'm asking for 1 every 20 seconds. And in the success function, you see the logic here in JavaScript that takes those X, Y, and Z acceleration vectors that I'm getting from PhoneGap and turning that into equations of motion to make the ball move around. Basically, I compute the ball's velocity, its acceleration, etc. Do some bounds checking to make sure that if it's impacted one side of the screen, I reverse its velocity in that direction. I've got a damping factor in there. I think I ended up setting that to 0.6 so that each time the ball bounces against the side, it loses a little bit of its momentum. But you put all that together, and at the end of the day, I moved that ball image using CSS, just repositioned it on the screen, and we create a pretty convincing illusion there that the user is rolling that ball around the table. Again, without PhoneGap or something like it to fill that gap in the HTML5 API, I wouldn't be able to build this type of application. Okay? Any questions about that? Do you still like what you see? Does this look compelling? Better than writing it 4 or 5 times, right? And not just writing it 4 or 5 times, but, you know, it's hard enough to be an expert on one platform, isn't it? It's really hard if you got to be an expert on multiple platforms. I know a lot of people who know iOS inside out, a lot of people who know Windows Phone 7 inside out. I don't know many people. In fact, I don't know anyone personally who's an expert on both those platforms. Throw Android into the mix, perhaps BlackBerry, and wow, all of a sudden it looks really good to have something like this to abstract the differences between those platforms. Yes, sir? That's a great question. The question is, can I debug this JavaScript? You can't debug it while it's running. Here's what I do, and it's what almost every PhoneGap developer I know do. Before we actually deploy any of this to a phone project of any type, we test it in a browser. We can use the F12 development tools, for example, in IE to set breakpoints, step through the code, or the equivalent of that, the Chrome developer tools over in Chrome. Once I actually package it up, drop it into a phone project, I've basically lost the ability to set breakpoints and step through it. So you try to get it as finished as you possibly can before it even goes into that PhoneGap project. And that may change in the future. In fact, I think it will, but for today, that's kind of how we do it. All right, back to the slides here. So another API set that PhoneGap gives you, besides the accelerometer, is a Compass API, which is pretty cool. In fact, again, I've got 2 versions of a phone Compass built. One is a native Windows Phone app, another is a PhoneGap app, so you can compare the 2 side by side. But the Compass API is pretty simple. These are the methods that make it up. If you just want a one-time fix on the direction that phone is oriented, you can call getCurrent heading. More commonly, we call watch heading. If you're going to build something that actually looks like a compass, you need a continuous stream of callbacks indicating which direction the phone is facing. So you do what I'm doing here, you call watch heading. Now, at 50 millisecond intervals or 20 times per second, my success function will be called, and I'm given information about true heading and magnetic heading. My experience is that true heading tends to be a lot more reliable on mobile devices than magnetic heading, so that's what I use. The compass is something else that some platforms require you to express in the manifest that you're going to use. For this next demo to even work on a Windows Phone, I have to put that highlighted line into my application manifest. I also have to put a line in config.xml that I submit inside the zip file that I submit the PhoneGap build, so it will put a similar flag in the manifest for Android as well. But once I've done that, it actually works pretty well. So once more, let me switch back over here to my phone and let me show you two versions of this Compass app, one as a native app, the second as a PhoneGap app, and I'll let you tell me whether you can see the difference. So we'll go back to full screen right here, and I'll first run the native, wow, that was, the ball was going crazy. I'll first run the native version of this application, which I called Compass Demo. Now, Windows phones, like most mobile devices, whoops, it's going to actually have to calibrate here, which means I have to pick it up and wave it around. Let's see. Oh. That's really, there's all kinds of things for it to get caught on up here. Let me try one thing. I'm going to ask it to run again here. I realize you can't see it, but you will in a moment. I needed to wave it before I clicked OK. So let's try that one more time. Okay, so wave it around. Windows phones, like most mobile devices, in order to get compass headings, actually use little devices called magnetometers. They're very sensitive to magnetic fields emanating from electrical devices and things. I don't know how accurate this is going to be since I'm so close to lots of electrical stuff, but it seems to think that south is that way. Now, I have no idea. Does anyone know, is south roughly that way? Okay, you're as clueless as I am. But you can see here in the native app, hopefully, that needle will continue to point about the same direction all the time, even as I rotate the phone around. And again, I'm using the native Windows Phone Compass API that actually didn't exist in Windows Phone 7.0, but did show up in Windows Phone Mango. Now let's look at the PhoneGap version of the same application. So I'll go back to my PhoneGap demos and run PhoneGap Compass demo right here. All written in HTML and JavaScript now, and it looks basically the same on the outside. Now, as I move it around, you'll see that I'm not getting quite as many refreshes or screen updates per second as I'm getting in the native version, but I think you would agree with me that it's probably good enough the way it is, especially since I can now push this thing out to Android, iOS, and other things, and have it running on a lot of different devices. So, back to Visual Studio here. Let's take a quick look behind the scenes at how that application was written. And as you'll see, it was pretty simple. So let me open my PhoneGap Compass Demo project. And all I'm doing in here is doing pretty much the same thing you saw on the slides. When this application starts up, I call navigator.compass.watch heading. I'm actually asking it, I chose 20 milliseconds. Because that's the time interval or callback interval I was using in the native version of it as well. Then basically, this method right here is being called each time there's a new compass heading to report, nominally 20 times a second. And then I do some math. There's actually a little math required to make sure when the needle wraps around from 0 to 360 that it doesn't jump around. And the main reason for that is this. See this code right here and down here? This is averaging code. One thing you'll find in programming sensors on mobile devices, whether it's an accelerometer, a compass, or what have you, the data streams tend to be pretty noisy. In fact, for the Compass API, if I just take the raw heading data coming in each callback and move the needle to that position, it looks really unnatural. The needle is real jittery. It's constantly moving around. What I was doing in the native version of this app is using a simple little averaging algorithm to smooth out the data stream and alleviate some of the noise. I'm doing the exact same thing here. I'm doing it in JavaScript here, but it makes that compass needle movement feel more fluid and more natural. If you're interested in seeing just how bad this can be without that averaging code in there, then you can just comment that out, and you'll see that it makes you nervous just to watch it. So, makes, as we say back in the States, would make you more nervous than a cup of coffee. But with a little bit of averaging in there, or you could use a low-pass filter algorithm if you preferred, you can make that appear pretty natural to the user. So once more, an example of a type of application we can write with PhoneGap and with HTML5, but that would not be possible without PhoneGap because HTML5 lacks the necessary API that we need. And I think you sense a theme here. There are other APIs in PhoneGap. There is a camera API, for example, for accessing the camera. I'm going to show you how this works, but I'm not going to demo it because it doesn't work on my Samsung Focus. It works in the Windows Phone emulator, but it throws an exception every time I try to call it. There are bugs in PhoneGap. After version 1.3 was released, remember that was the first one to support Windows Phone 7. I found a lot of bugs and documented them, sent repro cases to the team at Microsoft that built it. They fixed all those in 1.4.1, but there's still a few bugs out there. But once they get that fixed, I'm confident this will work as well on a Windows Phone as it does on others. The camera API is very, very rudimentary. There's one method in it, and get pictures. It can be used to bring up on a Windows Phone the built-in take a photo UI that the user, where the user sees a viewfinder, they can move the camera around, click the shutter button, and take a photo. Or it can be used to access the built-in photo store on the camera. In the case of a Windows Phone, the media library. This is the PhoneGap code that allows me to take a picture. I can change one thing, this little highlighted term that you see there, and tell PhoneGap that instead of letting the user take a picture to give me a picture in my code, instead I want PhoneGap to pop up whatever native media library UI that phone has so that the user can select a picture. That also throws an exception every time I call it on a Samsung Focus, so I can't demonstrate it for you on a real device. The camera is something else that on Windows Phone 7 and some other platforms does require special flags in the manifest. This is how you enable camera usage in a Windows Phone app. In config.xml, to run this on other platforms, you'll need to include a feature element that indicates this application uses the camera as well. Now, another API is the Contacts API. In Windows Phone 7.0, there was no Contacts API. In 7.1, Mango, they introduced a native Contacts API. Virtually all other mobile devices in their operating system have contact APIs. As you can imagine, what PhoneGap is doing is providing a simple JavaScript API that sits on top of that native phone API to give you access to the contacts. You can actually read and write contacts, although not all platforms support that. But here's kind of how it works. If I just wanted to enumerate all of the contacts on my phone, this is the PhoneGap code that does it. I begin by creating a contact find options object, setting multiple to true, then ask it to find all the contacts on the phone. Basically, it calls my onSuccess function. Notice how much of this is asynchronous here, by the way. Once it has enumerated the contacts, I then have an array of contact objects which have a bunch of properties with names like name, display name, phone numbers, emails, so I can enumerate all of that information about that contact. If I wanted to target that query a little bit more and do some filtering and bring back just contacts that have the letters HILL in them rather than enumerate all contacts, I could make this change here using the filter property of that contact options object. I'll tell you this, I wish PhoneGap went a lot further here. Basically, the only way it can filter what it brings back is by doing searches for a text string inside the contact's display name. We don't have the capability to do a query based on something that's included only in the phone number or only in the email address, but at least we have something that we can use, given that HTML5 does not yet have a contacts API. Now, this too is something that you have to enable on Windows Phone and on Android. Here's how I enable it in Windows Phone. Again, To enable it on Android, you do that through a feature element in the config.xml file that you include in the zip you submit to PhoneGap build. Now, I've got one last demo to show you here. Let me go back. And there's something else I want to throw at you in this demo. So let me run this thing on my phone. We'll switch back over here. Let's see, here's the camera right here. Let's go to full screen with it. One of the things that PhoneGap does not do for you, doesn't even attempt to do, is provide nice UI elements, buttons and list boxes and things like that. In this next demo, not only am I using HTML5 in PhoneGap, I'm using jQuery Mobile, the new version of jQuery that sits on top of jQuery Core and provides UI widgets and other things to mobile devices. So you're going to see all of it rolled into one package here. But I'll warn you in advance, you're probably not going to like what you see. Watch this. I've got a couple of hundred contacts on my phone here. I'm going to run a little application that uses PhoneGap to enumerate those contacts and display them in a jQuery mobile list view. So let's go back to my PhoneGap samples. PhoneGap contacts demo. Now it's enumerating contacts right now. You're starting to see the jQuery mobile list view control, which provides a built-in filtering option. Now you see the raw contacts, and now CSS is being applied to format those contacts. Now, had this been a native app, I could have gotten that to display almost instantaneously. The fact that we're layering HTML5 here and PhoneGap and jQuery Mobile, and the fact that jQuery Mobile relies very heavily on CSS, and Windows Phone's browser is based on IE9, which is very fast at some CSS-related things and very slow at others, means I have an application I would never put in a customer's hands here. Watch what happens when I start scrolling through these contacts. Interestingly enough, if you pass this up to PhoneGap build, try it on an iPhone or on an Android device, the scrolling is smooth as silk. I expect that that'll change someday. There is a team at Microsoft that is working to improve the perf of IE9 on the phone and stuff. It's kind of early. But the big reason I wanted you to see this is I want you to realize PhoneGap is not a panacea. It's important when you build for these different devices to deploy and test on the devices, and you're probably going to see some wide-ranging differences in performance. But better to know about that up front than to put that in a customer's hands sight unseen and have them not be very happy with the result. So that is a quick look at the state of cross-platform mobile development today. Is it perfect? No. Is there enough there to make it enticing, perhaps interesting, to prevent you from having to write these things multiple times? I think there is. Last thing, if you would like a copy of these examples I've shown you, you can go to this URL at your convenience, and you can download them. I'll make sure that URL is good for at least a couple months. In fact, the truth is I'll probably forget about it and never take it down. But you can go to that URL at your convenience, download a zip file containing all of those samples. I think we're out of time. So thank you very much. Enjoy the rest of the conference.